We thank you all for taking time out of your schedule and joining us with this event. I am Ram Kumar, Assistant Professor in the Department of Mechanical Engineering. It is a great pleasure in sharing a few words about our college and our department. Francis Xavier Engineering College is located at Tirunelveli city and it was established in the year 2000. FX Engineering College comes under the SCAD group of institutions and our institution has been offered autonomous status in the year 2019. We offer 6 UG programs, 10 PG programs and research centers. Our college has achieved many awards. Among all, I would like to list a few to your knowledge. We got Gold category for Industry Linked Technical Institute, which was awarded by AICTE CII survey. In Chronicle Engineering College survey, we achieved 3rd position among 19 engineering colleges in India. In Times Best Engineering College survey, our college has achieved 15th rank in Tamil Nadu and 108th rank in India. Apart from all, we got ICT Academy, Tamil Nadu Academic Partner Excellence Award in the year 2017. Regarding the Department of Mechanical Engineering, it is the largest department on the campus with 600 plus students, 30 plus faculty members and with good infrastructure facilities. We offer BE in Mechanical Engineering and ME in Industry Safety Engineering. The UG program is accredited by the National Board of Accreditation. We have FANUC Center of Excellence for CNC Center, BMW and Hyundai supported mechanical labs. Our department has signed many MOU with the leading manufacturing and service industries. Apart from regular academic activities, our students have been trained and imparted with various skill training programs and value-added courses. Our students are actively participating in many technical competitions, winning prizes and add glories to our department. We also offer international certified program on computer-aided design and non-destructive testings. We have also organized many international conferences, workshops and funded seminars. Today, we are organizing this online webinar. I hope the session will be more useful for all of us. On the final note, I welcome all the viewers for the session and hope we will have a productive time. Thank you all.
Mohamed Awad is working as a professor at Mechanical Power Engineering Department, Faculty of Engineering, Mansoura University, Mansoura, Egypt. He was a postdoctoral fellow in mechanical engineering in the Faculty of Engineering and Applied Science, Memorial University of Newfoundland, Canada. He received his PhD from Memorial University of Newfoundland in the year 2007 and his undergraduate degree and his master's degree from Mansoura University, Egypt in 1996 and 2000 respectively. His research focus is on the development of robust model for characterizing transport phenomena using fundamental theory. He is the author of 3 book chapters. He has published more than 90 papers in referred journals and conference proceedings in these areas. Presently, his research is focused on renewable energy and modeling of complex fluid dynamics, heat transfer problems in the internal flows. He is a member of American Society of Mechanical Engineers ASME. He was also a recipient of ASME International Petroleum Technology Institute IPTI award in the year 2005 and 2006. He won silver medal at 45th International Exhibition of Inventions, Geneva, Swiss from 29th March to 2nd April 2017. Currently, he is representative of Mansoura University in Research and Policy Committee members for the Mega Research Project among MIT and 3 Egyptian universities, Ain Shams University, Mansoura University and Aswan University from August 2019 to present. Also, he is corresponding member of the International Information Center for Multi-Phase Flow ICEM in Egypt. Dr. Awad has more than 23 years experience in teaching lecture and practical courses as demonstrator, assistant lecturer, assistant professor and Associate Professor at Mechanical Power Engineering Department. Dr. Awad is Associate Editor, Journal of Thermal Engineering. It has been a great delight for us to have such a wonderful chief guest. Kindly make use of this session. Over to you, sir.
Hey everyone, thank you for your invitation to give online lecture for engineering college student uh, uh, at your university in India. My name is Dr. Mohamed Awad. I'm working at Mechanical Power Engineering Department, Faculty of Engineering, Mansoura University, Mansoura, Egypt. Today, my talk is about use of Professor Bijan method as a tool in modeling of heat transfer and the fluid flow problem. Uh, I give just brief introduction about myself. I obtained my undergrad and my master degree from Mansoura University in Egypt in 1996 and 2000. Then I went to Canada in 2002 to do my PhD at Memorial University of Newfoundland, St. John's, Canada. Then I finished my PhD in 2007 and I worked there for 2 years as a postdoctor. Then I returned back to Egypt in 2009. As shown in my next slide, I have like 3 book chapter. Can you just go to next slide? In my, I have like 3 book chapter. The first one is about like thermodynamic optimization of heat exchanger using entropy generation minimization, and the second one is related to my thesis about two-phase flow, and the third one about like condensation in mini channel and macro channel. And this 3 link for my book chapter, you can download them for free. And next slide, please. Uh, when I attended like international conference of multi-phase flow 4 years ago in May 2016 in Italy, one of the keynote speaker is Professor Omar Matar from Imperial College London. He said in his talk about the next generation of operative tools for multi-phase flow, we need an, an, international collaboration. So I consider my talk talk today maybe as a chance to be a kind of cooperation between my university and your university. Also, currently I am representative of my university in yes, yes. uh, Currently I am a representative of my university in Mansoura University in a research project between MIT and 3 Egyptian University and Shams University, Mansoura University, and Aswan University. I am a member of research committee. Next slide, please. Today, the outline of my talk is like I will because the title of my presentation is like using of Professor Adrian method as a modeling tool in heat transfer and fluid flow problem. So I will give introduction about Professor Adrian Bijan, his award, how I know him. Then I will try to talk about this method, also such as entropy generation minimization, dimensionless pressure drop of Bijan number, asymptotic modeling approaches, scale analysis, prediction of the S-shape curve construction law, entropy versus entropy. There is other methods like heat line and mass line, but due to limitation of time, I skip some of his method. Next slide, please. Next slide, please. This is the first link is about the link of web page of Professor Bijan at Duke University, and the other link like you can find some of his biography in some article like his 60 birthday article in International Heat and Mass Transfer that was published in December 2008, and later 10 years after in his 70 years birthday, there is another article in the same journal which was published in November 2018, and when he obtained a medal from Franklin Institute in 2018, there is a new article about him in March 2020. All of this link you can download this article for free. Also, at the bottom there is the link of Google Scholar pages. So because I will refer to some of his book and some of his paper during my presentation. Next slide, please. This is a photo of Professor Adrian Bijan while during the ceremony of receiving Franklin Medal. He was born in 24 of September in 1948 in Romania. Then he obtained all of his degree, undergrad, master, and PhD from MIT. He authored for about 30 books and 650 journal paper, and he has like honorary PhD he has honorary 18 PhD from university in 11 countries. Next slide, please. Next slide, please. He has several awards recently. For example, he has a medal from American Society of Mechanical Engineering in 2017, then a medal from Franklin Institute in 2018 for thermodynamic and construction theory, which predicted natural design and its evolution in engineering, scientific, and social system. Several well-known people obtained this medal before since 1824, such as Thomas Edison. In this video, it will give which produced by Franklin Institute will give a short introduction about Professor Bijan and his construction law that he produced in 1996. Can you play the video, please? No, just there is video at the YouTube link. You can just play the video in the previous slide. Just there is yes. You can just raise the video, so voice of the video, so that it appears in my presentation. You can just if the voice of the video doesn't appear, you can just cut. You can notice in the background the tree shape and And this is the statement of the construction law. I mentioned this statement in my presentation also. Before I traveled to Canada to start my PhD there, I know Professor Dremjan from his textbook such as convection heat transfer and advanced thermodynamic. Then during my PhD in Canada, he taught me a short course in September 2005 with Professor Sergey Laurenti and my PhD advisor, Professor Yuri Muzoshkin. This short course is construction design of porous and complex flow structure. Next slide, please. This is Professor Adrian Bijan and Professor Sev Laurenti and my professor, PhD advisor, Professor Yuri Muzoshkin. Next slide. Uh, uh, now I will start with the first method. It's entropy generation minimization. After he Professor Ramjan finished his PhD in MIT, he worked for some time in as a postdoctor in University of California, Berkeley. Then he obtained a faculty position at University of Colorado. at that time in 1982 he published his first book about entropy generalization minimization. Uh, the in entropy generalization, in this method there are two components of entropy generation. First component due to heat transfer, and second component due to pressure drop. Then we define Bijan number as a ratio of entropy generation due to heat transfer to the total component due to heat transfer and pressure drop, and the range of Bijan number is from 0 to 1. At 0 means that all the entropy generation is due to pressure drop. At 1 it means that all the entropy generation is due to heat transfer. In my first book chapter, I make like as extension of short course part by my PhD advisor for applying this method to heat exchanger. I extend the literature review from the short course date 2005 until publishing book in 2012. Also, I have a review article about review of entropy generation of in macro channel that was published in advances in mechanical engineering in 2015, and this you can use this link to down this article for free. This article was cited by Professor Adrian Bijan in his new edition of advanced engineering thermodynamic book in chapter 11. Next slide, please. The also like Bijan number definition in thermodynamics, there is a second kind of Adrian dimensionless Bijan number that we can use in other application such as fluid mechanics, heat transfer, and mass transfer. In the field of fluid mechanics, this dimensionless number was introduced in 1988, and it can be defined as shown in the equation at the bottom. Bijan number equal to pressure drop delta B divided by square of L divided by product of dynamic viscosity times kinematic viscosity. Next slide, please. In 4 years later, it was published a comment in International Journal of Heat and Mass Transfer that we in the application of heat transfer, like cooling of electronic equipment, we use air as working fluid. Prandtl number for air is 0.72. If we approximate this value to 1, and as we know, Prandtl number is ratio of like momentum diffusivity to thermal diffusivity. So in the denominator of the previous equation, we can replace nu by alpha. So this new equation that we can apply it in heat transfer, Bijan number equal to delta B times L squared divided by nu times alpha. Next slide, please. While I was working in my book chapter, an idea comes to my mind that if we are dealing with mass transfer application, we can as the previous equation, we replace like nu by alpha. So in this equation, we can replace nu in the original equation that was introduced in 1988 by Mason Giuseppe capital D. And this new equation was Bijan number equal to delta B of times L squared divided by mu times D. Next slide, please. After I publish this idea as a new definition of Bijan number in Signal Science Journal, one of previous PhD student of Professor Bijan, Professor Jose, he mentioned that we can, in the original equation, in the denominator, we have like mu times nu. So if we can express like remove mu and replace mu as density times nu, then the original equation will be Bijan number will be delta B or L square divided by rho nu square. And using the analogy between fluid mechanics, heat transfer and mass transfer, we can replace nu square by alpha square for case of heat transfer, and by d square in the case of mass transfer. And this idea was published as a joint work in 2013 and as extending Bijan number to a general form. Next slide, please. After I published this second paper, I received a comment for a German professor. He mentioned that they have like a dimensionless number called the Hogan number, which is defined as bottom delta bill delta B over L capital divided by L cubic to divide by rho V square. From this equation and the previous equation, we can see that the physical meaning of Bijan number is Bijan number dimensionless pressure drop number, while Hogan number is dimensionless pressure gradient number. And for the case L capital equal flow length L capital equal to Casas length L small, like the case of a square duct, both of these two dimensional number are equal. I published this idea as a Hogan number versus Bijan number. Then in 2014, I apply Bijan number for as application on Bogus Media by writing an alternative form of Darcy equation, which is Bijan number equal Q to L cubic divided by permeability times nu. Next slide, please. In 2015, there is a French research group mentioned in their paper in International Journal of Multi-Phase Flow that there is no need to introduce Bijan number, because Bijan number can be seen as a combination of Euler number and Reynolds number. Then this is the reason I published in 2016 my paper, the science and the history of Bijan number. And in that paper, in International Journal of Heat and Mass Transfer, I mentioned that the concept is false because, for example, one of well-known dimensionless number, which is Bicklet number itself, it's a combination of Reynolds number and Prandtl number. Next slide, please. And because Journal of Signal Science is an open access journal, so this is if you need to read the previous publication in details, you can using the above link to down of all of my previous publication. The last paper which is about the science and the history of two Ph.no number, it's published not an open access, and this is the link. And at the end of my presentation, I leave my email address, so you can, if you need this paper, just email me and I will send it to you. Next slide, please. Next slide, please. Now we will talk about another method by Professor Adrian. He introduced, it's like intersection of asymptote. I will show after a few slides plot for application of this method, but I applied this asymptotic modeling approach in my PhD thesis. And here I give you the link of my PhD thesis. You can download my PhD as a PDF. Also, my second book chapter, I about two-phase flow. You can find a section about using asymptotic modeling approach in two-phase flow. In my PhD, I apply this method for two-phase flow in large scale, such as circular pipe, and in a small scale, such as mini channel and macro channel. During after I finish my PhD in 2007, I apply this method during my PhD in other applications, such as like liquid two-phase flow. While in my PhD, I was dealing with gas liquid two-phase flow. Also, I apply it in other application in petroleum industry, such as porous media and fracture. Next slide, please. In my recent comment about a paper in applied thermal engineering that was published last year in 2019, and this is the link. I give like many reference from reference 4 until reference 20, the list of where I applied this method in different applications. Next slide, please. For example, from reference, my reference 4 is about like conference paper for applying this method in circular pipe. Then my PhD thesis, then I apply it in convective heat transfer for rotating disk. Then, but this not related to my PhD thesis. And then I apply it during postdoctor in like in liquid and pipe and fracture. Next slide. And in porous media. After I returned back to Egypt in 2009, I apply it like in also two-phase flows. My PhD advisor like asymptotic generalization for the Lockhart-Martinelli method of two-phase flow, and in two-phase flow modeling in macro channel and mini channel. Then I apply it in other heat transfer problem, such as like thermally developing flow in parallel plate. Next slide. Here also link for my PhD. Sorry, link for my second book chapter. Also, I apply it for prediction of wall friction factor in horizontal annular flow, and I have a picture for this from that paper, and I apply it like in other applications, such as reference 1516. Next slide, please. And also I apply it in like in microgravity condition in convection heat transfer for wedge shape. So if you need any of this publication, just email me and I will send you the paper. Next slide, please. Here, like figure in asymptotic method. In asymptotic method, we have like two asymptotes. One at low value of x-axis and one for a high value of x-axis. And near the interaction of these two asymptotes, we try to know the solution either from like available data in literature or from like carrying out some experiment or carrying some CFD simulation. Then, as shown in this equation, the only unknown is the fitting parameter or b. By solving this non-linear equation, we can obtain the b value. For example, in this photo, I have one line which represents the equation of fraction factor in laminar region, which is equal f equal 16 over Reynolds number, and the other equation, it's like Fanning fraction factor equation in turbulent region, f equal 0.079 divided by Reynolds to power 1 over 4. And near the interaction of these two asymptotes, which is near like 1200, I obtain the solution from like Wallace book. Then by solving this equation, I obtain the solution. But in that equation, it's like 1 over f, for example. Next slide, please. Also, Professor Adrian Bijan, in his book and his paper, he introduced a new concept, which is skill analysis. Skill analysis is simple is a method to teach the physics and correct the scale of the problem at hand. Although it's simple, it requires a deep understanding of physics of the problem, more so than many other existing methods. For example, for laminar flow in circular pipe, we know that F is equal 16 over Reynolds number. Using the scale method, we can find that Fanning friction factor is proportional to 1 over Reynolds number. Next slide, please. There is a new publication about like new insight into the definition of Bijan number that was published in July 2020, and this is the link of this publication. In that publication, the author used the concept of skin analysis in their paper. Next slide, please. Now I will introduce another method which is related to S-shape curve. Professor Adrian Bijan and Professor Salve Laurent in 2011 and 2012, they mentioned that S-curve phenomena can be found in many applications in our life, such as spreading of population, the spreading of radio and TV, the growth of readership of one scientific publication. They predicted the behavior of S-curve history analytically as atomic mechanism flow, one by convection alone, and one sorry, the predicted analytically the behavior as two mechanism flow, as one as fast and one is as slow. In one region, the exponent of the time is 1.5, and in other regimes, the exponent of the time is 0.5. Using this method that they introduced, in their publication. I have two publication in 2014. Next slide, please. This is my two publication. One is published as a comment, and the one published as a short note. Uh, in his new book, The Physics of Life, the Evolution of Everything, Professor Adrian Bijan published also about the S curve behavior, and I published a short review about this book in Energy Journal. Next slide, please. The next method, which is related to construction theory. You have watched a short video for about like 4 or 5 minutes in this presentation. Professor Adrian Bijan introduced this method in 1996, and this is construction website, construction.org. And if you are interested, there is in the past there is 12 conference about construction theory. For example, I met Professor Bijan in Romania in 2017, and then if you're interested, the next meeting will be in May 2021 in USA. In next slide, please. This is the statement you mentioned. You see this statement in the video also for a finite size flow system to persist in time. Its configuration must evolve in time such a way that it provided either access to its current. Next slide, please. According to his construction theory, Professor the game Bijan shows this form of generation of flow configuration as like an animated movie where one screen is replaced by another screen on which the current flow was greater is. The construction law is the time direction of the movie toward flow configuration. That flow more is Professor Adrian Bijan see the construction law as a universal principle of evolution which apply in many fields from physics to economy. Next slide, please. As you see in a short video which is available at YouTube, you watch the tree shape, and you can find this tree shape in cover of his book Design and Nature: How the Construction Law govern evolution in biology, physics, technology, and social organization. Next slide, please. Next slide, please. I have a recent publication about like using construction theory in my paper thermofluid and entropy generation analysis of newly designed loop for construction cooling of a square blade. Next slide. This is a link of paper with research from India. Also, from the point of view of thermodynamic, Professor Adrian Bijan was published in 2014 an article about lack of physics about the interagency concept. This concept was introduced by Search Group in 2007, where interagency has defined as equal 0.5 times Q times T. And you can notice that the name interagency has 4 letters from the word entropy, and also both of them end with letter Y. Next slide, Also, I mentioned in my first paper about to show that this entrance concept is false. For example, if we assume that entrance is constant between state 1 and state 2, uh, from this equation, E equal point Q1 times T1 also equal point half times Q2 times T2. If like here, Q1 is greater than Q2, this means T1 is less T2. In other words, the greater heat transfer ability belongs to the body with lower temperature. This is confusing. Next slide. And this is the list of my publication, which is related about entrance to show its wrong concept from the first one as measuring of heat transfer. Next slide. Until the last one in Journal of Thermal Science. In this last one, also I commented that to show that the origin of the graphical method of temperature heat diagram is belong to Professor Adrian Bijan. He developed his method while he was doing his postdoctor in University of California, Berkeley. And this is the link for the last one. You can download for free. Next slide. Recently, about like 1.5 months ago, Professor Adrian Bijan published in a paper related to thermodynamics, and this is the access for paper you can download for free. Next slide, please. This paper is posted the front page of the journal as shown in this link, and I will show you the picture in the next slide. Next slide, please. And this is the photo from his paper. It's about like evolution of thermodynamics from like 1851 since the second law until like introduction of construction law in 1996. Next slide, please. Last month, June 2020, there is a great interview with Professor Adrian Bijan about the meaning of the life. He refers to in this talk he talks about his new book like the physics of life, the evolution of everything, and also his new book that was published in 2020. Also about like 10 days ago, there is a virtual conference, thermodynamic 2. He talked about his new book about in this talk he covered like several topics such as like science and freedom and so on. Next slide, please. Some of this work which I mentioned is visual, such as using a synthetic method during my PhD, and my postdoctor was funded by Natural Science and Engineering Research Council of Canada. Also during my PhD, I obtained an award from ASMA International Petroleum Technology Institute Scholarship, also Petroleum Canada Young Innovator, and during my postdoctor, my research was funded by Atlantic Innovation Fund. Next slide, please. And here I mention like my university email, my Gmail, and my WhatsApp. So if you have any question, please to contact me, or you if you need any of PDF of the papers that I mentioned in my presentation. It's my pleasure to send you in the paper that you want. Thank you for your invitation again, and thank you. Okay, now I finish. Yes.
On behalf of FXEC, I extend a very hearty vote of thanks to the Honorable Speaker, Professor Mohamed Awad, Mechanical Power Engineering Department, Mansoura University, Egypt, for accepting our invitation and rendering his lecture on the thrust area of the present scenario among his busy schedule. We are very thankful to our management, respected GM Development Dr. Jayakumar Sir, and our beloved Principal Dr. V. Velmurugan Sir. Our sincere thanks to Dr. Joe Patrick Sir, Head of the Department, Dr. Jinatul Farida Abdul Kani Madam, Dr. I. Nidhi Manikam Sir, Professor Jeremy Jabba Samuel, Professor Saravana Kumar, Professor Ram Kumar, Technical Expert Mr. Jason, and all our colleagues for their support. This webinar was made successful only because of the well-wishers, followers, and the participants of this event. On behalf of the institution and management, I sincerely extend my thanks to all. Thank you.